Nick Tucci is a subject matter expert in geochemistry who consults for the mining and energy sectors. He has extensive experience in hydrogeochemical and hard rock investigation, site characterizations, acid rock drainage predictions, and mitigations that has been a team leader for remediation and reclamations for a dozen of legacy and active mine sites throughout the Intermountain West, including Montana. Nick is a leader in a rapid site characterization using innovative field and analytical techniques. He uses advanced geochemical and mineralogical identification techniques and methodologies to inform sampling plans and strengthen conceptual site models to reduce uncertainty, time to meet project goals, reduce life cycle costs, and moderate and satisfy regulatory compliance. Please welcome Nick.
Good morning, everybody. Good to see my microphone is working, pointer's working, so we're ready to go. So I was just waxing nostalgic with Lauren earlier at breakfast today because this was the first conference that I ever presented at as a graduate student back in 2003, and so now it's 2023. That was 20 years ago, and I know a lot of people in this room have been here a lot longer than that, and Warren, Gunnar, you guys have all been here a lot longer than that. But it's kind of special to me, and so I remember it very vividly because it was the first presentation I ever gave at a conference, and I was a graduate student, and I was pretty nervous. I might have been a little bit hungover, and I just flubbed it. And I did a terrible job, and I was counting the uhs and ums, and I just started reading like word for word and I had a 30-minute slot, and I was done with it in 10 minutes, and I ran out of the room, and I ran to my advisor at the time, and I looking for like some comfort, and he's like, yeah, that's pretty bad. That was the worst I've ever seen, he said, So like, oh man, I'm feeling like such a failure. And it was back when this was at the Quaituk Nook in Polson, and they have a nice little reception area. And so I sat down on one of the couches there, and I'm just miserable, and I'm like, I'm never presenting again, And then you guys started coming up to me one by one, and just saying, giving me encouragement and talking about my project and showing interest in it. And that gave me the courage to do the next presentation and the next presentation and the next presentation, and eventually I got okay at it, and I come back every year, and you guys do the same thing. And so this is my favorite conference that I attend, and it will continue to be. And I was at lunch the other day with Dustin Wasley and several others, and they were iterating the same sentiment. And even after how we're going to retire, we're still going to show up as old curmudgeons to this conference and help encourage the next generation of professionals. So thank you guys for listening to my talk. I'm too going to be talking about selenium, and it's a bit of a difficult topic because we're in a bit of a changing world right now with climate change. And I was at that same launch with several folks, and they asked me, well, are you still nervous? And I go, why would I be nervous? And they said, because you're going to be talking about climate change to the mining industry. And I'm like, well, shit, I wasn't nervous. But we're at a bit of an interesting inflection point in this conversation, because I think we've all gotten over arguing about the science of it, and now we're starting to talk about what we could actually do about it. And so I'm interested in your guys' perspectives on this talk. So, all right, I'll move forward. And so why is this a big issue? I don't know if you guys are familiar with Joseph Toth or not, but he's kind of, if you've taken an intro to hydrogeology or hydrologic modeling course, you're familiar with the Toth problem, which is this concept of steady state conditions. All of our sites are in this dynamic equilibrium, and even though there are these changes due to wet cycles and dry cycles that occur at our site, with not only constituents of concern, but with geochemical controlling variables and actually groundwater tables as well. And climate change is sort of messing with this dynamic equilibrium cycles. With these wetter and drier cycles, where some areas of the country are going to be wetter, sustained, and some of the areas of the country are going to be drier. And these are changing a lot of variables that control the concentrations of constituents in groundwater and surface water. We're seeing this at some of our sites right now in Montana. I'm seeing a lot of this in Southwest United States. We're seeing a lot of this in Southeast United States. And so by US EPA, this is kind of on their website. These are all the ways that climate change can affect constituents of concern at mine sites. You have fate and transport, toxicity, efficacy of treatment, exposure, and sensitivity. And I included this picture because there was a lot of white space over here and I needed something, so I picked this. I don't know if you guys remember back in 2021, in Florida, they had that condominium collapse on them in Surfside, Florida. And I thought about this just recently, and one of the root causes actually was increase in salinity from saltwater intrusion. And so you had induced corrosion as a result of saltwater intrusion, and you had a condo collapse about this. And what I found interesting about that, I was just in Boston talking with Mark Haley, who was one of our geotechnical engineers. They're actually worried about this very issue in Boston. He's told me, and this is not, he's not a liberal guy. He's pretty rich. I don't know if you've seen our name, but Haley is one of the reasons, why we exist. They have until 2070 to figure this out. They believe that this is going to start to happen in Boston. And so, I don't know, that's, I'm going to be pushing 90 back then, at that point in 2070, but if I am, I'll be sitting back in that corner right there with Dustin Wasley, and I'm going to be going, I told you so, waving my cane. But I live pretty much in this region right here in my career. I deal with fate and transport of constituents in the environment, toxicity and efficacy of treatment mitigation. And what I'm going to talk to you today mostly is about fate and transport of selenium and how the geochemical parameters governing the mobility of that in the environment are changing. And they're changing to the point where we're seeing some pretty significant increases in selenium at some of our sites. And so this is the why I can't really talk about my client. He wanted to keep the site anonymous, but it's in the Verde River watershed of northern, kind of central Arizona. It's right north of Phoenix, outside of Prescott. And you got the Colorado Plateau up here, if some of you are familiar with that. It's fairly large drainage. My site is in the middle of it that I'll be talking to you about. There's a lot of good public information about it. USGS monitors this area. They have SNOTEL stations up in the Colorado Basin or Plateau. They have several stream gauging stations, and they have a precipitation station right at the site. So a lot of good information, could compare selenium concentrations to the climate cycle pretty well. So it's a good case study. And so here's the real issue. When they started monitoring compliance back in 2007, life was good. And then, even in 2015, sitting pretty with selenium. You have selenium concentrations here. This is the point of compliance right here. And right about 2018, you've seen a spike in selenium. So what the heck is going on? That's when I got a call, right about here. And in southeastern United States, there are 3 climate cycles that are being impacted by climate change right now. There is the El Nino Southern Oscillation Cycle, which is a 4 to 7 year cycle. There's the Pacific Decadal Oscillation Cycle, which is a 20 to 70 year cycle. And then there is the Atlantic Multi-Decadal Oscillation Cycle, which is a 27 year cycle, 70 year cycle as well. All of these are being impacted by climate change, and we'll get into that a little bit. And we've linked, spoiler alert, we've linked those changes to these increasing concentrations, which I'll get into. So the sites here, Colorado Plateau is up here, and it's dominated predominantly by the Supe group, which is the sort of acts as the recharge area for the site for groundwater for the aquifer. A lot of snowpack up in the Colorado Plateau. These units have pretty high concentrations of naturally occurring selenium. And so what you have here is you have snow melt. You have three factors going on. You have snow melt happening up in the plateau. You have water running through the Verde River. And then you have local precipitation acting in this area. And you could see that these areas are red pretty much is where you see elevated concentrations of naturally occurring selenium in the units. And so what we hypothesized at that time was you got an increase in wet weather events happening, which I will get into. You have an increase in snowpack levels up here, and so you have all the stuff necessary for the mobilization of naturally occurring selenium, which we're seeing at our site. And I'm very thankful for the USGS. If there's anybody from the USGS here, thank you. You did a lot of groundwork that helped us prove our case, because this area, because it's in an area where there's high levels of geogenic selenium, there's high levels of selenium in groundwater, and there's high levels of selenium in surface water. And so we didn't have to go out and look for background locations. All this work was sort of done for us. And it showed that even during normal conditions, climatically, there's very high levels of concentrations in surface water. This site is downgrading of our site. It is, this area right here is located proximally to areas where the Supai group is outcropping in this area right here. And as a result of that, you have very high levels of selenium in both surface water and groundwater, and they exceed the regulatory limits for our point of compliance wells. USGS also linked these, did the job of linking these high exceeding concentrations to geogenic sources in the Supai group along the Verde River watershed. And so when you compare selenium concentrations to annual precip, you don't get a good trend until you start to look at the 5-year cumulative running average. This is how the USGS kind of quantifies regional impacts for climate conditions. And you can see during the dry conditions, we had relatively low concentrations of, we had low concentrations of, there's a bit of an offset. So here, you know, during relatively low, below average climatic conditions, we had very low concentrations of selenium. But then when we got into wet weather conditions, we started to see increasing concentrations of selenium. It's not a one-to-one record. It's not a one-to-one ratio. There's not a really, if you were to actually try and correlate just selenium concentrations to precip, it's not a good correlation because there's two other variables that are impacting and have controls on selenium concentrations. There's snowpack. You can see there's a pretty decent correlation with snowpack. And then there's Verde River discharge. You can see there's a pretty good correlation with discharge. And so all three of these variables are acting independently to control selenium concentrations in groundwater. We worked closely with the regulatory agency, and they were concerned that there were selenium sources on site that we weren't accounting for. So we did a deep dive here, and we sampled all of the waste rock, you know, all of the other inputs that they add to their system for their processing, and we looked at all these things, and all of them were non-detect except for copper slag. These three, which they use as an amendment to their operations, they add this stuff. They actually import it and add it to their operations. And it doesn't stay on site very long. It's contained within holding pads, and it leaves with the product. And so we have very good consistency with background concentrations in the area of selenium. Mostly everything's below detect. So long story short, there's no selenium on site. So it's not a site-induced condition. So you put together this geochemical model. Lauren actually talked about this pretty well. Selenium is a redox-sensitive species. It's mobilized and very oxidized. This is an EH-pH diagram with those of you who are not familiar with these. Inorganic constituents they're not the only controlling variables, but they are typically the master controlling variables, pH and redox conditions. And so if it's tan color, yellow color here, selenium is in the solid phase and it's tied up in the aquifer. If there's highly basic conditions or oxidized conditions, selenium wants to be in the mobile phase and it'll be mobilized in groundwater. So we're oscillating back and forth between these cycles, where during dry conditions, selenium wants to be pretty much in the solid state, tied up in the aquifer, but during wet weather conditions, it's mobilized. And you actually see this at many sites across the United States. You see this in the phosphate patch during the freshet, during high levels of snowmelt. You see spikes in selenium down in Soda Springs. So this is kind of what we got going on during the dry conditions, and we've been experiencing dry conditions for about 7 to 8 years. Selenium's tied up in the aquifer, but when you get wet weather, those geogenic sources are being mobilized. And they're staying mobilized because of climate change. So the adaptive management approach we worked out here is we engage the regulatory agencies as early as we can. Just like Lauren said, there was a very collaborative approach. I presented before the regulatory agencies 5 times. Trying to give them the comfort level to show that this was, 1, this was a geogenic issue, and 2, there was nothing the mine was doing to induce mobilization, right? This is actually happening because of climate change. And so the agency was very willing to discuss this. They actually helped develop and guide the strategy through the iterative process of regulatory engagement. And I think that was the key to success, was early and frequent engagement with them. We used pretty novel statistical approaches that at first the agencies were not comfortable with, but we were able to fit the data, the climate data, to the existing selenium record pretty well, and we had a good fit. And so we were able to predict selenium concentrations based off of what the climate cycles were looking like. And then once we had that best fit scenario, we used regression techniques to predict selenium concentrations based on historic wet weather periods. And so we have a 100-year data set for climate data, both precipitation, snowpack, and river discharge, and we were able to use that data to predict at the peak wet weather conditions what selenium concentrations would look like in the aquifer. And then the results of that statistical calculation were used to calculate what site background levels were, which then we input and were able to amend the permit level to those background concentrations. And so here's all that climate data. We had climate data going back to 1939, so almost 100 years worth of data. This is our water quality record right here. So, we only had, 17 years, not even 12 years of data, of selenium data. We were able to fit an equation that using this climate data to predict selenium concentrations pretty well. And then we're able to say, okay, back at these anticipated high levels of wet conditions, what would selenium look like in the aquifer? And that's what we did. And so basically, this is the statistical calculation for selenium concentrations. It's the impact that precip has on selenium, geogenic sources of selenium, the impact that river discharge has on selenium, and the impact that snowpack has on selenium. And all of those factors combined to predict what selenium looks like in the aquifer. And there's a lot of advantages we use principal component analysis and multivariate regression techniques. There's a lot of advantage of this. And the key advantage of this is that it doesn't depend on stable water quality conditions because we're not stable. In a lot of statistical analysis, you have to have stable, you're probably all familiar with this. You have to have stable concentrations it's a key assumption. And we violated that on most statistical analysis. So we had to kind of invent a new statistical approach that did not rely on stable water quality parameters. And so your eyes are going to begin to gloss over because this is a statistical summary page. I won't spend a lot of time on this or I'll put you to sleep and you're all wanting to take a break. But this is a collinear regression. And what this tells you is the if there's any collinearity between these three variables. We have these three predictor variables. We have precipitation, discharge, snow water equivalent. How much and to what degree are all three of these factors having an impact on selenium concentrations? And what this tells you is that all three of them independently impact selenium concentrations. So we have to use all three of those variables to predict what selenium concentration is going to be in the aquifer. This is our output file. This is our equation right here. Selenium concentration is equal to this factor times precipitation plus this factor times discharge, this factor times snowpack. So you can see which variable is more important here, the most important here. It's the precipitation, followed by snowpack, followed by discharge in that order. We did an ANOVA test to see how statistically significant this was. We got a p-value of much, much less than 0.05. We had a coefficient of correlation of greater than 95%. The model predicted the selenium concentration very well, very accurately, and this was the data we needed to ultimately convince the regulatory agency and get their buy-in that yes, we can go ahead and use that equation to predict future selenium concentrations in groundwater so that we could then go ahead and adjust the compliance level. And so in conclusion, and sorry if I went over, I don't know where I'm at. PCR worked really well. It was able to determine natural variability of background selenium based off of those three predictor variables. We had data, we only had selenium data from 2007 to 2021, which were pretty much dry years, but we were able to fit that equation and predict what selenium would look like with the data that we had from 1937 to 2021. And it turns out that we were able to calculate a background selenium concentration of about 0.21 milligrams per liter in this aquifer. We were able to take that and adjust that natural variability, that background level, to the amended permitting level of 0.21 milligrams per liter. So, I guess if you guys were to look at the climate cycle, which I showed and I didn't make this point, but we're not as wet, we're not in very wet years in Arizona. Actually, if you were to compare the other wet periods, they're much higher than they are now. You have a lot more precip back then than you did now. But in Arizona, it's predicted that the climate is going to be drier, but they're having very frequent, very intense precipitation events. And that is actually inducing the mobilization of selenium. They're much more intense. They're shorter duration, but they're a lot more, and because of that, there's a lot more infiltration into the aquifer. And that is changing the game with respect to geochemical mobilization of these constituents. And so food for thought, I'm interested to see if any of you guys are also seeing these changes on your sites. But have you noticed these kind of temporal changes with any kind of constituent on your site? Have you considered the impact of future temporal trends in water quality data at your sites? If these temporal trends were to occur, I want you guys to start thinking about what other constituents would you need to actually prove out what we're able to on this site. And then have you considered taking a more holistic approach to your site conceptual models, looking at temporal trends of not just your constituents, but other potentially geochemical mobilizing constituents? doing novel statistical analysis to predict trends, and then taking a look at your regional geology and hydrogeology to kind of look at what your climate is looking like. And then in Montana, we're going to start seeing a 100-year storm event every 20 years or so. And so that's going to change things. So shameless plug so mark your calendars for the 40th American Society of Reclamation Sciences. It's going on in Boise. When is it? It's June 4th through the 7th, and you could register there. So, I do believe that mining is going to be the only solution that can solve climate change, but it's also going to present the industry some challenges in the future, and we have to be ready for it. So I hope this talk was thought-provoking, and thank you for your time.
Could you go back to slide 8?
Yeah.
So for that, I understand you don't have selenium data prior to 2007. Do you have more of that 5-year cumulative data prior to 2007? Because it seems that there must have been a preceding higher value for that trend line going into 2007 to have those elevated selenium at that point.
And I do have that plot. I don't have it with me, and it does go above the average. It does go above the running average. This really is a typical, El Nino oscillation event, and it's a 4 to 7 year cycle. So you have these 4 to 7 year cycles that are oscillating back and forth. And so if I were to predict the 5-year cumulative average, it would go above this line here. But there's a lag, right, between what you see happening at the surface to what you see happening in the groundwater, because there's transport times that are associated with this. So you see an offset, right, between dry cycle here, dry cycle there, precip starting to increase here in 2014, but we don't start seeing that increase until 2017.
So would you suggest that prior to 2007 you might have had peaks of selenium above the annual?
Maybe. Potentially, yeah. I don't know, but what I do suggest is that it's getting worse. Well, it's not getting worse. The conditions are becoming more conducive to the mobilization of things that are mobilized under oxidizing conditions, like selenium, right? Because you have these very intense, short durations, these just downpours, and that all soaks into the ground, high dissolved oxygen in that stuff, mobilizing selenium, and once you get dissolved oxygen in your aquifer, and it doesn't go reducing again, selenium will stay mobile in your aquifer for a while. And so we're starting to pick that up here, and I'm saying what I'm saying is I don't really know what they were back here, but I bet you they're higher now as a result of that change in climate. And we looked at storm intensity, and storm intensity has picked up. The years 18 and 19 and 20 had very significant mobilization effects to the effect where it was damaging infrastructure, both on the mine and in the town of Clarksville. So it's not just the wet cycle, it's actually the storm intensity that's mobilizing in this case.
Let's just do one more question.
So Nick, you came up with the 0.21 milligrams per liter as your background number, but that's really based on that equation that you put forth. So what in the future if things change and it goes above that 0.21 for regulatory compliance?
So that's a great question. I looked at and I found several publications on what the source of selenium and what the magnitude of the source of selenium is in the SUPI group. And I was able to run a quick model on, okay, if I hit this stuff with very high oxygenated water, how much of that selenium can I mobilize and what would be the equilibrium of that mobilization? And it was higher than this, but not by much. So that's what gave me the confidence. And I didn't present that here because I didn't think I had the time. But that geochemical modeling and what could we expect in the future was important to determining overall what we were comfortable with. And I felt like, 0.21 is still 5-fold higher than what we're seeing right now. And so I felt comfortable with the fact that I was protecting, my client, but I also thought that it was the right thing to do because of the modeling that I looked at and where we were at in consideration of that model. So I was comfortable with that concentration. I didn't really want to go any higher than that though, based off of the modeling results. Did that answer your question?
Well, great. Thanks, Nick.
You bet. Oh, yeah.